So instead of continuing with charts, let's jump into actually looking at how this works. So let's start in the development environment. Here I have an integrated rational developer for System Z as well as rational team concert. And I've got in this environment a set of projects that I normally interact with. As part of this, I'm going to be focusing on the Homestead application. Let me give you a little background on the Homestead application. It's actually a back-end component to a front-end Bluemix application. So we have a Bluemix Homestead application that's a storefront that was fully built and developed in Bluemix. It is integrated into the environment as an iPad application, iPhone application, so that you have access to this storefront. And the data that's being hosted is provided by a back-end Kick service. And so we've built that Kick service, and we've built up the definitions in order to build it. So we'll go into a little description of the application and how you build it and the artifacts to build it, and then we'll go into a little bit about deployment. So in this case, you can see in my rational team concert environment, I have the concept of builds, and I can have multiple builds. In this case, I have a Kix build as well as a WS bind build. So I'm building the backend Kix load modules, but I'm also building the service definition files that are necessary for the mobile REST calls. These are building the JSON files that exist. I have my source control, and in this environment I actually have only one stream. And in this stream I have two different components. Again, it's my Kix backend load modules and my front-end WS bind files that I have access to. I also have a set of work items. That's how I do my planning, my understanding of the environment, what's going on. And I can build queries based on that. I can query the environment to see what work items are available. I can look at plans. In this case, I want to look at all the Homestead-related work. And I can see here that I have a number of work items that are related to building this application. The fact that I've got a build definition, the fact that I've built up the application, and I can track work. Right now I have this change that I need to do, though. I need to make a change in the code, and knowing me, I'm just going to change comments because as part of a demo, I really don't ever like to write code. So we're going to change a comment line to show how I can work in the environment. If you'll notice, this is an editor that's been provided by Rational Developer for System Z. So in this particular case, it understands COBOL. Obviously, there are editors that understand PL1, understand Java, understand C, understand the language that you're developing for, so you have the context of the information. When I make a change in the environment, the system recognizes the fact that I have made that change. And I have a view in my pending changes view that tells me I have this new unresolved change. Now, I've already loaded my source code here because I wanted to make it easy for me to change, but I'll show how I loaded that in a minute. So I have it from the SCM, I have it locally so I can interact with it, and I've made that change and it appears locally on my system as an unresolved change. I can then check in that change. So I will check in. When I check in that change, it now becomes an outgoing change. The process of checking in the change actually only checked it into my repository workspace. That's my personal copy of the changes that are in the environment. My personal copy allows me to save my changes in the environment so I don't have to worry that my machine, I lose my machine, or I can move between machines and interact with the same code. Other people can also look at my source, if I allow it, in my repository workspace, so I can do things like code review. Now, as part of a change, I want to associate that with the work item. Work items track the work that you're doing and allow you to easily understand all the changes that were made as part of a work item. So I'm going to associate this to an existing work item. If I didn't have an existing work item, I could have created a new one, but you really want people working on existing work items or existing tasks to get done. Once I've made my change, then I should appropriately build it in the environment. And I could request a personal build, and I could build the code. In this case, I'm going to do what most developers do and go ahead and deliver this change to the stream, because I'm going to assume the change that I made is, of course, going to work and is going to be buildable. So when I request a build, I'm going to request a team build. In this case, I'm doing a dependency-based build, so it's only going to build the files that have changed in my environment. If I wanted to do a personal build, I could have submitted a personal build, and it would have built them into my own personal files. If you see here, you'll notice I had a personal build that I have done recently, in fact, earlier today when I was making a change. So in your build history, you easily see who's done what, whether or not they've done a personal build, whether or not it's a team build, but you have clear visibility to what's going on in the environment and a clear understanding. Now this build that I'm submitting is a slightly different build in the sense that this build is integrated into my deployment technology. So it allows me to, once I do a build, have that build report into the deployment capability so that I can then do a deployment of that build. And if I look here, I can easily go in and see what was built in my last build. I can see that in this environment I happened to build one COBOL program, and I can see in my build log that easily I created this move my version, and I created a new version in the deployment technology. So I'm going to jump over to UrbanCode Deploy and show what that has done in UrbanCode Deploy. If I go into this environment, you can see UrbanCode Deploy provides me a vision of applications within my environment. I can also look at components and a number of other things, but we're going to start here with applications. In this case, I have a number of applications in the environment, and the one I'm focused on right now is this Homestead application. Homestead application has two environments that are part of it. I have a test environment and a production environment. And right now, my test and production environments look similar, or look the same, actually, because they have the same capabilities deployed to them. And I can actually see that because I can see they both have 9 versions in addition deployed. But if I want to be sure, I can easily compare the two environments to see that, yes, the two environments are matching in the environment. So I have a clear visual understanding of what's in test and what's in production, and if there had been any differences, I'd be able to easily see that. If I want to deploy a new change into the environment, it's simply a matter of requesting that change. Now when I do a deployment, I do it based on a deploy process, and I'm going to show a little bit about that in a minute. But let's just say I want to do this deployment process. When I do that, I can choose the version I wish to deploy. And I get a list of all the versions that have been created that I can deploy. Now if I look at this list, you'll notice I actually have 2 versions from today. One is that build I was looking at just a few minutes ago, and the other one is the build that I actually just did while we're sitting here talking. So I'm going to select that new version to deploy. Simply select version to deploy. I'm not going to change the Homestead bind version because the bind files didn't change. There were no updates. There's no new versions to deploy. So I'll just deploy that, and I'll submit that for deployment. So what will happen is it will go off and do this deployment, and it'll deploy this in the background while we are, well, okay, so it's going to fail. Demos always do that, don't they? We'll look at that in a minute. Let's go back to the versions and the process to see how this process was defined, to understand a little bit more about the processes and how this deployment would work. If we look here, this is the deploy process that I used. It actually does a deploy of the Kix application and of the bind file. Now these are components that are being deployed, and so this shows us that we've got two different deployments, two different components that are part of the same application that we're deploying at the same time. So let's take a look at the actual components that make up this application. Starting with the Homestead Kix application, we can take a look at its processes. And here we see a simple deploy process for a component. I'm copying the artifacts, deploying those artifacts, causing those artifacts to be activated, and running a command to do the appropriate database binds, because this application has a database backend. So I have the ability to do the normal tasks or normal activities that I would do in a deployment. If we take a look, there are actually a number of capabilities that are provided out of the box out of UrbanCode Deploy to allow you to interact with systems. For ZOS, we have a number of built-in commands that have been added as of the 6.1 release in June. And then for the distributed environment, we have numerous activities that one might need to, or tasks that one might need to do when deploying a distributed application. And there are new use of these. In this case, we haven't added in all of the various different plugins that are available, but in UrbanCode Deploy, there are plugins that are provided for things such as integrating with WebSphere, and so doing my WebSphere application deploy, or integrating with numerous other middleware capabilities, MQ, or whatever you have in your environment. Those plugins allow you to easily do the deployment to that select middleware and interact with it based on definitions provided by the middleware. So you're reducing your need to write scripts for automation. You're reducing the activities required from the standpoint of a deployment engineer, and you're simplifying this so that any user with appropriate background can build up this deployment process, and then whoever it is that's responsible for doing the deployment can simply just use the interface and do that deploy and not have to worry about knowledge of understanding the underlying middleware necessarily. Now, this doesn't remove the requirement entirely from understanding the middleware from everyone, i.e. if you end up with a problem, you are going to end up looking at the logs and understanding, but all those are pulled back into UrbanCode Deploy, and we'll take a look at that as well. Let's look at one of these processes that has successfully deployed. So we're going to go back and look at the Kix environment and look at its versions that have been deployed in the environment. I'll take a look at one of these back here that has been deployed successfully, and we'll look at this one, and we'll see that first off, as part of a deployment of an object, I have a clear visual of what was part of that deployment. So what made up that deployment artifact? In this case, it happens to be a ZOS artifact, and so it's incremental. You have the different pieces that are visually there. If I go into its history, I can see all of the times it's been deployed into the environment, and I can view its request. This was a successful deploy, so I can see each one of the activities that happened as part of this deploy. And I can easily see the output from it to see what happened as part of this deployment. So I can easily visualize what was done. And in this case, you can see I have even highlighted as part of the environment the indication that says that the deploy was successful. In this case, the activation of this program was successful. So all the logs are brought back for you so that you can easily understand, you can debug any problems, and you have a clear understanding of what happened and how something was deployed. If I go back and take a look, I see every instance where this particular version was deployed in the environment. So I can see if it's been deployed in the test environment, production environment. I've got that clear indication in the visuals for the definition. Now this Homestead Kicks application I was showing you was a ZOS component. Let's take a look at a component that looks not quite like a ZOS component. So in this case, this is the bind files that are part of the environment. And if I look at this component and I look at its version, this is one of the versions that have been deployed, you see this time I actually see the artifacts that are part of that deployment, and I see that I have a download action. So in this case, these artifacts are Java artifacts, or bind files specifically, that have actually been stored in CodeStation. And so I have them in the CodeStation repository, and I have the ability to download them. But you see that they're different because this is a distributed artifact and it is a complete artifact. Every time I do a build of this artifact, I'm going to do a complete replace of these items so that I have the full application component piece in the history so I can redeploy it anywhere I wish. In the Z components, they're all incremental deployments because on the Z platform we normally deal with an incremental deployment. But you'll see with this, I also have the same history information, and I can go back and see the history of how it was deployed. I can see the execution that happened in the same environment. So I have a clear understanding of the deployment in the environment. So we started out with the beginning with a development process. And as we moved through, we showed that I have the development artifacts that move in to being built, compiled, and then deployed into the environment. And so the full life cycle from a developer standpoint has been completed, at least from an initial trial. Now let's delve into a little bit more deeply some of the capabilities in the environment and some of the things that you can do. The idea with showing an overall picture is to show that from a development standpoint and an operations standpoint, I can easily see that complete flow. If we go back and look at this build that I did, this is the build that I ran that generated the load modules. And if I go look at the build report here, I will see that these were the files that were generated as part of that build, and that this is the build label itself. If we take a quick look back at UrbanCode Deploy and the version that I created, you can easily see this was the new version that I created. And if you do the comparison real quick, the numbers match. So I can see that the build label is what is used to tie between these two so that I have an understanding of this is the build that created this item, and I have the traceability of that information. I can also update the work item that is associated with this to say this is the UrbanCode Deploy version, and link it in as well in that way so that you have full traceability in the environment between the items. Also, if we drill down into this version, you can see that they show that I've got the same component pieces. I have the DBRM and I have the load module from each of the items. And so I've got the information about what was deployed in both places, and I have that traceability and that understanding between the two environments so that you have a deployment tool, a capability that allows you to do deployment that gives you that full traceability. The tool, as in UrbanCode Deploy, lets operations teams interact and do the capabilities that they need to do, but it also allows the developers to do the deployments that they expect. One other thing that might be nice to look at is a visual understanding of what's happened in the environment. So when we're looking at a life cycle of an artifact, beginning with the change that happened in the development process, I want to be able to understand what was deployed when. And I can easily get a visualization based on a calendar or a schedule of what was deployed, when it was deployed, and visually see that. I can also schedule things for deployment, so I can schedule a deployment if I need to. But in this case, I'm showing what has been deployed. And I can move back to the month of June to show that the deployments have happened on an unusual frequency in this case. If we go back a little bit further, we can drill into the information with these deployments, and I can obviously show it in weeks that are more clearly showing the deployment information, or drill into a day, and I can see the information clearly about what was deployed. You'll notice that it's coded based on the environment it was deployed to, so that you can understand what's being deployed in the environment and visually understand that. Now, back to the developer themselves. As a developer, I showed you a simple edit of a COBOL program, but I want to drill into this a little bit more. This is a modern IDE allowing me to interact with my system, and I see things such as I can't find a copybook, so I don't have that information. I left that error in here intentionally to show that there are the ability to see copybooks that are local, so I can interact with this copybook and understand what's going on. So include files, I can easily see the information that's related to that. Or if it's missing, it's not in the environment, I get that kind of warning to understand the system doesn't see it. Now in this case, this copybook actually exists on my remote system, so I could set up my environment so that it would find it on the remote system as well. But in this case, I like having at least one error so I can show it in the environment. It also has the ability to show more details about the program, program flow, open and perform hierarchy, so I can understand the flow of the application. I can get details of the application and understand what's going on. Now this is a relatively small program, relatively boring in many ways, so it doesn't have a lot of details, but it provides the function necessary of the KICS application and gives me the visualization that I need. The other thing that's important to understand is that in this environment, I'm using the Eclipse Client because that's what I as a developer would use in the environment working as an IDE. However, Rational Team Concert is intended for all sorts of users, not just development users. So in this case, of course I lost my link. I can also access the system as, say, a project manager or an administrator in the environment, and I want to interact, or as an executive wanting to look at what's going on in the environment. Assuming I can type my password. I'll log in, and you can see that, well, you can see that I'm an administrator on the system. So we'll go take a look at the Homestead application, or an application from a change in configuration management standpoint. So here's the Homestead application, and I get a set of dashboards that are provided to allow me to visualize and understand the environment. This allows my users to interact with the system without having to have the Eclipse IDE. So users such as project managers, executives can easily see what's going on in the environment, can easily get the feedback and understand, and have a visualization that they expect. And you can build reports, and you can build additional information in these dashboards to provide the information that you need in order to give you the value that you want. Now, the other thing that's important in this environment is to understand whether or not my application actually worked. So I've done my building. I need to be able to run and see, did my application work? Did it run successfully? And I also might want to make it so that I allow other teams to interact and do their development before I'm done. So I can do things like use Rational Integration Tester to build up a set of test cases and a set of stubs. In this case, I've built up a test case that validates my Homestead service. And so what it's doing is validating the REST service call, sending the REST service call, and checking the response to make sure that I'm getting the data that I expect. And this test can be run anytime I deploy my application updates to make sure that it is serving the data correctly. Based on that validate kick service test that I created, I also created a stub. And here you can see my stub definition. What this stub definition will do is I can have it provide a virtual service using the Rational Test Virtualization Server that allows me to virtualize the service, allows me to have that running so that the mobile front-end team, the team that's working in the Bluemix environment, can easily access the stub, all while I'm still working in the background to do my application build. And so that stub can run. The front-end team is always going to get a response of Mr. Mouse and this set of data, because that's what I've set up in my virtual service. And so that's what they'll receive. And then once the actual application is available, I can turn on the application, I can turn off the stub, and they'll access the virtual service. Now, since I mentioned it, in this case where we used Bluemix in the front end, and we used our back-end ZOS server system, it's important to understand Bluemix. Current instance of Bluemix is public cloud. So it's sitting in the public interface. You can go out and play with Bluemix and build your own environments. The Bluemix public cloud talking to my private kick system, obviously there's a few firewalls in between. And so we used Cast Iron Live to connect the two. It's important to understand the building of the application and building the component pieces were all tracked and traced using development tooling, i.e. in the case for the back-end part, Rational Team Concert, and actually the Bluemix part is done the same way using DevOps Services, which is Rational Team Concert in the background. If I go back to my UrbanCode Deploy, one of the other process configurations I wanted to show you in my components was the fact that I not only built a process that would deploy the application, actually in my application components, I not only built a process that would deploy my application, but I also built a process that would do testing. So one of the good things in the environment with UrbanCode Deploy is I can not only deploy my application, but I can also integrate it such that I'm running integration tests so that I can run any test suite that I have. So I can run my integration tests. I can validate that my service is actually responding. And in this case, you'll see that I also stop the stub. And so I stopped the stub in the environment. I allowed the application, now the front-end application is using the real interface rather than just the back end. So hopefully through this, I've shown you the deployment capability, the integration, and the lifecycle traceability from the front end all the way through the back end, making sure that you have consistent capability to deploy and interact whether or not you're using the same type of application, the same development environment, making sure you can do the right thing in the right time. There are numerous clients who have provided descriptions and references on how they use the environment and what they have done in their productivity improvements. And just looking at a couple of these, I think it's important to point out Nationwide Insurance is one that has significantly improved their code quality, reduced their downtime, and increased their on-time delivery. And one of the key pieces of this was true integration of their teams. They truly brought together all of the people involved as part of the project, provided them integration, provided them the interaction, the traceability, using a combination of these products so that they have visibility, they have the capability to see what's going on in the environment. They really broke down the development barriers by bringing the Z and the distributed teams together, and by their improved testing, they are finding defects significantly sooner such that they're having fewer problems in production. Another one of these examples, the Kix development team, is one of my favorite examples. They have significantly improved their development process and made it, if possible, for them to deliver their product on a shorter development cycle by truly modernizing their development process. They started out on a set of, what the best way to describe it is, old tooling that they've been using virtually since the beginning of Kix, because that's what they had, and that's what they were using, and that's what they were comfortable with. But they knew that they wanted to modernize. They wanted to be the modern Kix, the modern environment. And so as a development team, they transitioned to using Rational Team Concert to truly improve their collaboration, truly give them modern tooling capabilities. So they're using Rational Team Concert, Rational Developer for System Z, modern development tools to build their modern capabilities so that users can interact with them. The other part about that that's interesting is by having the development team that's building the tool use the modern tooling, they have now produced tooling for Kix in a consistent way in the same environment. So all the Kix tools that we provide are built on the Eclipse platform, integrate into the development tooling so that it's a full seamless environment, and from a developer standpoint, you have the environment you need and the expectations. So through this, hopefully I have explained the value of bringing teams together, of breaking down the walls, of increasing the collaboration in the organization, making sure that improving the development process and having a true lifecycle collaboration, ensuring that from the beginning of the development all the way through operations, you have the clear traceability, and you have the common tooling and common support to ensure that your teams know what you're doing. You're focusing on operations, making sure the operations team is properly integrated into the environment. I mean, one of the things Rhonda pointed out in my background is I spent quite a long time in what used to be called Tivoli, now Cloud and Smarter Infrastructure organization. And so I spent a lot of time in the systems management organization in the operations side of customer shops. And IBM very calmly moved me into the rational organization to build development tooling. And that was in part response to my, well, it's development fault. So that when I moved, I could no longer say, I wasn't going to say it's operations fault. So we need the teams to work together. And it takes sharing of people, it takes sharing of thought processes, it really takes people's transformation. People understanding the sides of this picture, working together better to collaborate, to understand that everyone needs to work together in order to provide true business value. This isn't a short strategy. This isn't to pick up a tool and now you're DevOps. It really is a lifecycle transformation. Just customers who have looked at doing it and improving their processes overall, the DevOps process is a journey. It needs to be thought of from an enterprise scale, an enterprise understanding. Based on that enterprise understanding, then you focus on the individual projects or the areas where you will get the best business value. Where is your improvement area that you're going to win the biggest value? Focus there, start small. Start with small projects and move it to the complete organization over time. But by having an enterprise understanding of what you plan to do, you'll have a clearer understanding where to go in each one of the steps. And when you get through this process, even if you've had individual teams starting in different places, they can all come together and provide the value to the organization. And each of those individual teams can easily be starting with different problems. Those different areas have different problems. But then they become the center of competency for that shift within the organization. One organization focused on automated tooling for tasks, automated testing, one focused organization on deployment, and each of them develop the competencies that share across the organization. It's important to get started. It's important to begin this process. It is this transformation. As I said, we're seeing a number of customers starting down this path, and it's from mainframe to mobile. It's every part of the organization that needs to play, that needs to participate, that needs to be part of this transformation. Hopefully this was a useful discussion, and if you have any questions, I haven't seen any show up, but I'm not sure if they can. If you have any questions, I'm happy to answer them.
So Rosalind, let me jump in there. We purposely muted all the audio so they actually can't ask any questions.
But can they type?
Yes, they can type them in the question box there. If they can see the little question plus minus in your window there, your GoToWebinar window there. But if you guys aren't able to type in that window, what we do as a follow-up is we contact you to see if you're interested in receiving additional information in the presentation and if you have questions. Because for us, it's all about informing and educating, and again, that's why we're really excited that Rosalind is partnering with us in this DevOps space. So I don't see anybody typing any questions, but I assure you I always get emails after these things.
Well, hopefully this was helpful.
Very helpful for me, and I know I did get a ping from one of the guys on the phone who happens to be in my Google circles. So he was saying this is really cool stuff, and he would be really excited to see this come about at WellPoint. So